Thank you all for joining today's webinar on NFPA 70E, Electrical Safety in the Workplace. This webinar is offered to you in part by the USF 21D Consultation Program, the USF OSHA Training Institute Education Center, and the Sunshine ERC. This presentation is not a standard or regulation, and it creates no new legal obligations. It contains recommendations as well as descriptions of mandatory safety and health standards. The recommendations are advisory in nature, informational in content, and are intended to assist employers in providing a safe and helpful workplace. The Occupational Safety and Health Act requires employers to comply with safety and health standards and regulations promulgated by OSHA or by a state with an OSHA-approved state plan. In addition, the Act's General Duty Clause, Section 5A1, requires employers to provide their employees with a workplace free from recognized hazards likely to cause death or serious physical harm. The webinar will be 1.5 hours in length. We will reserve approximately 20 minutes at the end of the webinar to answer questions. You may experience some delays during the presentation as we transition between speakers. A few ground rules before we begin. You've been entered in listen-only mode. Please enter your questions as they arise into the questions box. All questions will be answered at the conclusion of the presentation. If you should experience any technical difficulties during the presentation, please contact your department's IT help desk. A copy of today's PowerPoint will be sent to the email address you entered at the time of registration within 5 business days. Finally, a survey will be distributed towards the end of the webinar. It'll take 2 minutes to complete. Your feedback is very important to us as this allows us to continue to offer quality webinars that are beneficial to you. My name is Nicholas Giroux. I'm the Marketing and Communications Specialist for the USF Safety Florida Consultation Program, and I'll serve as your moderator this morning. Today's panel of experts consists of Keith Brown. Keith Brown is a safety team leader and supervisor with the USF Safety Florida 21D Consultation Program. He has over 25 years of experience in industrial safety and health, of which the past 20 years have been with the OSHA Consultation Program in Florida. He works with employers throughout the state, providing on-site OSHA consultation services to a broad spectrum of industries, including light and heavy manufacturing, medical, construction, maritime, and agriculture. Mr. Brown is an authorized OSHA outreach trainer for the construction industry, general industry, maritime industry, 10 and 30-hour classes. Mr. Brown is also the course chair for multiple courses at the USF OTEC Education Center. Mr. Brown attended the University of Florida and has a degree in building construction from Santa Fe College in Gainesville, Florida. Next is Noel McCaddy Jr. Noel McCaddy Jr. is a safety and health consultant with the USF Safety Florida Consultation Program. Ms. McCaddy has over 15 years of experience as a quality, safety, and environmental manager with the USF United States Air Force and civilian contractors. His OSHA certifications have authorized him to be a general industry trainer, disaster site trainer, construction trainer, and maritime trainer. He's been a hazmat on-scene incident commander and helped to implement ISO 14001 and the Occupational Health and Safety Assessment Series 18001. He's trained in OSHA, EPA, NEBOSH, and industrial safety standards, and proficient with National Fire Protection Association regulations, NFPA. Ms. McCaddy has a bachelor's degree in science in occupational safety and health and in environmental management. Without further ado, I'll now turn the webinar over to Dr. Brian Warwick, the USF Safety Florida Consultation Program Director.
Thank you, Nick, and good morning to everyone. First, I'd like to take this opportunity to thank our distinguished panel, Mr. Keith Brown and Mr. Noel McCaddy, for taking the time off their busy schedule to share their expertise in this relevant topic. I think the audience will be well served by your selection. We've all heard about laborers who have been electrocuted after their crane boom contacts an overhead power line. An HVAC contractor electrocuted in a crawl space, or a journeyman wireman electrocuted after contacting energized switchgear components at a power plant. These were actual fatalities that were investigated and found that they could have been prevented had they been in compliance with the latest safety code and standard. If you're in the mining industry, it's even more problematic because electrical accidents are a leading cause of mining fatalities and account for over 6% of the fatalities. When compared to other industries, mining industry has an electrical fatality rate approximately 8 to 12 times the rate of all US industries. While a number of workplace electrical injuries have declined in recent years, the risk of shock, electrocution, arc flash, and arc blast remains a significant health and safety concern. Each week, nearly 3 workers die and thousands are injured by electrical hazards annually. Our intent in this webinar is not only to familiarize you with the OSHA standard, but to share some of the best business practices as it relates to electrical safety. But before we begin, however, a quick word from our sponsor. So the USF Safety Florida program is the state's official safety and health program administrator. Not to be confused with OSHA enforcement where citations are issued or penalties proposed. The consultation program primary mission is to assist Florida's small businesses comply with OSHA standards, thereby eliminating workplace hazards that can potentially cause injury, illness, or death. Essentially, we help employers maintain a safe working environment. And while working with us, our services are free and confidential, and you're able to defer an OSHA inspection. We help keep employers profitable through avoidance of direct and indirect cost of injuries. We help keep employers profitable by avoiding OSHA fines and penalties. We also help keep them profitable by reducing their workers' comp costs due to the lower injury rates. And the saying, a safe workplace is a productive workplace, couldn't be further from the truth. Our team has more than 150 years of combined occupational health and safety leadership experience in construction, maritime, manufacturing, and agricultural operations, and a position in each region of the state. Our focus is on small employers with high hazard operations to help not only identify hazards, but work with the client in producing what we call viable, feasible solutions. As we look to building sustainable systems, our team is focused on helping employers develop customized health and safety management systems, where their program is continuously being reviewed, revamped, and renewed following a quality methodology. Our online tool, the Safety Rider, is second to none. It provides employers the ability to produce their own site-specific health and safety plan based on their own industry and specific hazards. The plan can be stored online for easy retrieval and update or file as a paper document. We also offer free DVD and online video streaming on a vast array of safety and health topics, to include the current electrical safety standards and also information on the COVID crisis. Some of the training are delivered in both Spanish and in some cases Creole. I urge you to visit us online at safetyflorida.com as we endeavor to make Florida the safest state to work. Another sponsor of this webinar is the USF OSHA Training Institute Education Center, for short the OTI. Based right here in Wesley Chapel, Florida, they can deliver expert training primarily in the southeastern United States. They offer outreach training program, trainer courses, and occupational safety and health standard courses in the general industry, maritime, construction, and disaster site worker. They also offer technical courses, as you see on the slide. And for those who want a more in-depth discussion on electrical safety, the USF OTI is teaching the OSHA 3095 Electrical Safety Standard class next week, March 8 to 11, virtually. You can sign up on the website, usfotiec.org. So without further ado, I now turn the presentation over to Keith Brown, who will start us off. Keith?
Thank you, Dr. Warwick, and good morning, everyone. I'm going to take about the next half hour or so and talk with you a little bit about OSHA and NFPA 70E. But before we get into that, let's take a look at a little video clip here. What we see here is a worker performing a task inside some electrical switchgear, and something terribly goes wrong. He's enveloped in an electrical arc flash, molten metal being spewed out at him. Now we have another worker who is actually coming into the scene and taken by surprise as well. So we ask ourselves, what went wrong and what could we have done to prevent this? Well, these are questions which are really, at least the second question, what could we do to have prevented this? These are questions which are actually answered by the NFPA 70 and NFPA 70E. And these are two separate documents under the umbrella of the National Fire Protection Association. And specifically, to give you a little background on them, just a little bit here. The National Electrical Code was first published in 1897 after interested parties in the insurance industry, electrical industry, architectural firms, and other interested groups came to realize that we needed to establish some kind of standardization for the use and the application of electrical services in the country. And so again, that evolved into the publication of the NEC in 1897. Well, National Fire Protection Association adopted it and put it under their umbrella in 1911, where it's been ever since. It's important to note that this is a purely consensus standard. It is not law. It is not regulation. But it's been made available for different organizations, public and private, to adopt and to serve as a guidance tool. And it just so happens that many city and county state agencies have adopted it to oversee the safe and standard installation for electrical systems in their localities. It was originally intended to be used by designers, installers, inspectors of electrical installations. When it comes to NFPA 70E, however, it didn't emerge until its first publication in 1979, but it got its origins in 1976, where a committee was established to develop a standard which OSHA hopefully would have adopted in its enforcement of workplace safety and health standards. Although it was created and published in 1979, unfortunately bureaucracy prevented OSHA from adopting the new standard, and so it remained as a consensus standard for all of industry and anyone else who wanted to adopt it. Its focus, whereas National Electrical Code was on electrical installation, the focus of 70E is on safe electrical work practices. How do we install these systems in a safe manner? And so I think it's important for us all to understand something that Nick mentioned earlier in his introduction of the program, that under the Occupational Safety and Health Act of 1970, Congress mandated that each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or are likely to cause serious death or serious physical harm to his employees. And that's referred to as the General Duty Clause. OSHA will use this clause as a means of citing employers when they are not able to use an OSHA specific standard or a standard which OSHA has adopted. If you look at Title 29 of the Code of Federal Regulations, and this covers labor, Part 1910.6 actually lists all of the consensus standards from organizations such as American National Standards Institute, the American Society for Testing Materials, Compressed Gas Association, National Fire Protection. The list goes on and on and on. But in 1910.6, there is a complete list of all consensus standards which OSHA has adopted by reference. Insofar as OSHA did not have to go back and reinvent the wheel, they were able to find standards which met the needs for enforcing safety in the workplace. Now, in this list, you will not find NFPA 70 or 70E. They have not and were not and have not been adopted by OSHA by reference. But rather, OSHA has taken discrete portions of the National Electrical Code for inclusion in many of its standards, subpart S in particular, as well as subpart K for construction. It's also important to note that the OSHA standards and those that it has adopted by reference are the minimum requirements for providing safety in the workplace. Again, these are the minimum requirements. Well, consensus standards are not enforceable unless they are formally adopted by organizations having authority or the teeth to enforce them. And we typically see organizations such as city, county, state, federal agencies having that authority. You might even think of a homeowners association might also be able to adopt a consensus standard, since in many cases its bylaws provide it some teeth or some authority to enforce those measures or those rules within its organization. So again, OSHA does not enforce 70E. However, OSHA can use it to support a violation of the general duty clause. They can use it to validate an issue that they identified as being a recognized hazard if it is so listed in a consensus standard. So we can look at the OSHA standards and basically equate them with what must be done, but then we can look at 70E from the standpoint of how do we do it. So within the Occupational Safety and Health Act, OSHA spells out responsibilities for both employers and employees. We see the same thing in 70E. The 70E requires employers to establish, document, and implement safety-related work practices and procedures. It also requires the employer to provide training on those work practices as well as those procedures to their employees. In terms of the employee, it's really quite simple. Employees must comply with the employer's work practices and procedures that have been created for their protection. In terms of hazard assessments, we see in many cases, and particularly in OSHA's personal protective equipment standard, where they require employers to assess the workplace for hazards and which might only be able to be addressed through the use of personal protective equipment. But they also require in their assessments that the employer address hazards through an established hierarchy of controls. We also see in 70E pretty much that same requirement, that the workplace be assessed for potential electrical hazards and that the employer must address those hazards through an established hierarchy of controls. And 70E goes so far as to spell out what that hierarchy of control is. First of all, priority must be given to eliminating the hazard. Can we create an electrically safe working condition where the hazard does not exist? Secondly, if we're unable to meet that hazard elimination, can we substitute a procedure, a piece of equipment? Maybe we might be able to take a 120 volt control circuit and replace it with a lower voltage control circuit, maybe, say 24 volts, AC or DC. If that's unable to be achieved, then we look at the implementation of engineering controls, such as installation of guards or barriers to prevent people from having access to the potentially hazardous issue. Awareness signs might next be considered to elevate individuals' consciousness of an electrical hazard that they're about to engage. We might also look at establishing procedures and utilizing job planning. Maybe that might even include lockout, tagout. Okay. And finally, if all else fails, we fall back on the use and selection of personal protective equipment to address electric shock and arc flash hazards. If we look at the organization, the layout of the of 70E, we see that it consists of 3 chapters, only 3 chapters, but there's a lot of information contained in each of these chapters. A great amount of emphasis and a great amount of text is dedicated to Chapter 1, Safety-Related Work Practices. And though it only has 5 articles, these 5 articles take up approximately 30 pages of the, of about 40 pages of the actual standard. There's additional information spelled out in 19 informative annexes, which are provided in these after the standard itself. And these annexes provide information on everything from reference publications for more information. There's a discussion on limits of approach. There's a sample electrical safety program that they provide, a discussion on risk assessment and risk control. Also, in Annex D, there's a means of calculating incident energy and arc flash boundary for different situations, and we'll talk about that more shortly. There's a sample lockout tagout program, as well as an energized electrical work permit sample as well. So there's all kinds of information, valuable information that the employer has access to assist them in providing that safe electrical workplace. Some definitions that are and these are only a few of the very many that are in the standard. Accessible. They spell out what accessible means by basically saying it admits close approach. You can come up close to a piece of equipment of an electrical nature, but only under certain conditions, which are spelled out later, okay? It also describes accessible as not being guarded or by locked doors or elevation or other effective means. In other words, the person ought to be able to walk right up to the electrical equipment without really any hindrance. Arc flash hazard. It's a source of possible injury or damage to health associated with the release of energy caused by an electrical arc. I think we all have seen an electrical arc. Probably one I know everybody has seen is lightning, okay? Another one, maybe you plugged in an appliance and you saw a little spark. Well, that was an electrical arc, okay? Risk assessment, very important definition here. An overall process that identifies hazards, estimates the likelihood of occurrence of injury or damage to health, and also estimates the potential severity of injury or damage to health, and determines if protective measures are required. That's a very important concept, not only in assessing potential electrical hazards, but really any hazard that might be encountered in the workplace. Mentioned arc flash. Well, here we have 2 of them. The first one, you may not be able to readily recognize it, but if you look closely on the left side of the photograph, you'll see a rod holder for an arc welding operation. So this is an actual arc flash, which is intentional and used to perform work. It's under the control of the worker. The photo on the right, however, shows a whole different situation where a worker is being enveloped in something that went wrong. This was not intentional. Okay, all of that, those bright sparks you see flying off to the right, that is molten metal. Very dangerous and no fun. Continuing with the definitions, arc flash boundary is a limit to how close you can come to an arc source, and they measure it at the threshold of where the energy from the arc measures 1.2 calories per square centimeter. Okay, and if you want to know how much that really refers to, well, 1 calorie, it's a measurement of energy which is used to raise the temperature of 1 gram of water 1 degree Celsius. So it may not seem like much, but when you start thinking about this level of energy applied over an area of maybe a couple hundred square centimeters, it adds up to a considerable amount of energy. Limited approach boundary is the limit at which a distance from an exposed energized conductor or circuit part can be approached. Okay, so, and this is really in terms of protecting someone from electrical shock hazards. Okay, we don't want to let an unqualified person get too close to a potential electrical shock source. Likewise, restricted approach boundary is an approach limit at a distance from an exposed energized electrical conductor where there's an increased likelihood of electric shock due to an arc over with inadvertent movement. In other words, you get too close and maybe you bump your arm or something, or you get startled and you accidentally come into contact with an energized component. Again, this is more of an electrical shock hazard boundary. Here we see a graphical representation of those boundaries. If you look at that center dot, that little globe on the interior of these two spheres, that's any point of an energized electrical source. Okay, it might be the end of a wire. All right, if we come out to that first sphere from that point, that's the closest we can get for a qualified person, somebody who's trained to recognize and work with electrical hazards. Okay, that's really the closest they can get to it. All right, and when we talk about approach, it's actually working distance, at least in respect to this parameter. And the working distance is that distance from the energized source to the face or chest of the person who's approaching it. So it's a working distance as well. We come out to that second sphere with the solid line, and we see that as a limited approach boundary. That's the boundary where we don't want anybody who's not qualified to go beyond that to stay at, or to not come closer than. Okay, and then that hashed line on the further out from that second sphere, that's our arc flash boundary. And this one, there's a lot of variation with the location of the arc flash boundary, and there's an actual calculation that can be made based on the voltage and the ampacity, the current of the energized source. So that's one which keeps people from getting burned or having molten metal spewed at them. Some interesting facts about arc flashes and arc blasts. The temperature of an arc flash can be as much as 35,000 degrees or more in terms of Fahrenheit. Sound levels can be damaging to the ears at 140 decibels. That's almost ruptured, well, that is a ruptured eardrum in an instant. Pressure waves of as much as 2,100 pounds per square inch can be produced by these arc flashes and arc blasts. The propulsion of molten metal. Metal can be thrown out at speeds upwards of 700 miles per hour. And this is a liquid metal, okay? Liquid metal, which will cling to clothing and skin, okay? And the arc flash, we heard that, we mentioned that arc flash boundary a few moments ago. The arc flash can kill at distances in excess of 10 feet. Again, depending on the equipment, the voltages and the currents that are involved in the arc flash and the arc blast itself. So how do we prevent electrical shock and arc flashes and arc blasts? Well, we can remove electrical hazards from the picture. If we're getting ready to work on a piece of equipment, do we have to work on it hot or energized? Or can we do whatever we have to do in a de-energized state? We want to do everything in a de-energized state, but there are situations where that may not be possible, which we'll talk about here a little bit later. We can remove electrical hazards by implementing a lockout tagout procedure, or we could establish an electrical safe working condition, which really isn't a procedure or a process as much as it is a state, okay? It's a state wherein all hazardous electrical conductors or circuit parts to which our worker might be exposed are maintained in a de-energized state for the entire time that the worker is exposed to that equipment, okay? In other words, it's maintained as long as it is needed to be. So if we look at it from a practical standpoint, if we can remove the electrical energy, we have no electrical hazards, okay? Like as I said earlier, sometimes there are situations where we're not able to work strictly in a de-energized situation or an electrically safe working condition. There are times which we might find that if we kill the power, we might be interrupting life support equipment, or we might be deactivating emergency alarm systems, or possibly even shutting down vital ventilation equipment servicing a hazardous location where they rely on that ventilation to prevent a greater catastrophe from occurring, such as an explosion. There is the infeasibility requirement that an employer must demonstrate that the task to be performed is infeasible in a de-energized state due to equipment design or the operational limitations that I just mentioned. So it's incumbent on the employer to make that infeasibility case before working on live equipment. So under Article 130, and this is in Chapter 1 of 70E, it states that if we're going to be working on live equipment, we have to have an energized electrical work permit. And that's basically required whenever work's is being performed within the restricted approach boundary, or there is an increased likelihood of injury from an exposure to an arc flash hazard. And this electrical work permit has to be documented. It has to be a on-paper instrument. It's also required that the employer conduct a shock risk assessment, and that assessment also be documented. The assessment is to identify the shock hazards. It's also to estimate the likelihood of occurrence of an electrical shock and the severity, the potential severity of that shock. It's also used to determine the need for additional protective measures, such as personal protective equipment. It's also used to establish limited and restricted approach boundaries so that we don't get people tangled up with live electrical equipment, okay? And this oftentimes, this limited and restricted approach boundaries can be based on the table which is in 130, and that's table 130.4 EA, which is for AC circuits, or B for DC circuits. And here's a picture of that table, straight out of the standard. As you can see, if you look up here at the very top of this list, less than 50 volts, not a problem. We don't worry about it. In fact, 70E really doesn't it doesn't apply to voltages or systems less than 50 volts. But let me ask you this. Can that less than 50 volts cause a spark? Can it cause an arc? Well, that arc or spark might be of a minimum amount of current. Would it be capable of igniting a class of a flammable or hazardous atmosphere? So really, we still need to keep in mind the potential for voltages even under 50 volts. But when it comes to electrical shock, it's really not considered to be a major threat at all. If we look at the 50 volts to 150 volt line, we can see that we have a limited approach boundary of anywhere from 3 to 3.5 feet, or rather 10 feet to 3.5 feet, rather, depending on if there are any movable conductors within that piece of equipment or within that scenario. And as far as the restricted approach boundary, just avoid contact. Now, if we go to the other extreme at the very bottom of the list, we see the 765,000 volts to the 800,000 volt range. And we see greater limited approach boundaries of 23 feet 9 inches for both the exposed fixed circuit part as well as the movable conductor. And we see 15 feet as a restricted approach boundary. So this is a very important table, again, based on voltages to establish our shock protection approach boundary. Looking at arc flash risk assessment, it's basically to identify potential arc flash hazards. It estimates the likelihood of a severity based on the design, maintenance, and actual physical condition of the equipment. And we can come up with this likelihood, the estimate of likelihood, based again on another table in Article 130, Table 5C, 130.5C. This risk assessment must also be documented, and we must establish an arc flash boundary. And we're given two options for establishing that arc flash boundary. We can either go to Informative Annex D to calculate the incident energy and the arc flash boundary, or we can again refer to another table in Article 130, 130.7 C15A or B, when the requirements of these tables are met. And we'll see that here shortly. The arc flash risk assessment will also allow us the opportunity to select the appropriate level of arc flash PPE based on either the incident energy analysis per our use of Annex D, or again, the use of Table 130.7 C15A or B. Here's a sample of the incident energy calculation in Informative Annex D. It can be, I'll be honest with you, it's a little bit beyond my mathematical ability. If I spent probably about 6 weeks, I could probably understand it completely. And so, but you can still, and probably if you're an electrical engineer or a good electrician, you could probably use this calculation to establish that incident energy level, or you can go to this table. This is 130.7C15A, which is for AC systems. And if you look at panel boards, the very first entry up here, panel boards or other equipment rated at 240 volts and below. And it has the additional parameters of 25,000 amp fault current with a maximum fault clearing time of 0.03 of a second and a minimum working distance of only 18 inches. You only have to have an arc flash PPE category of category 1 rather, and your arc flash boundary would be 19 inches. So we wouldn't get much of an arc flash out of this one. Whereas if you go down to the, let's say, metal clad switch gear, it's the third one from the bottom of the page. We're talking about switch gear rated at 1,000 through 15,000 volts with the parameters of a 35,000 fault current, a maximum of 0.24 of a second fault clearing time, and a minimum working distance of 3 feet. And we see here that it's going to require a Category 4 level of PPE, which is the highest, the most stringent PPE. And we have a arc flash boundary of 40 feet. That, as you can well imagine, is a significant arc flash potential. So we also have issues regarding, or a requirement rather, for labeling equipment. And while again, this is not enforced by OSHA, it is strongly recommended, okay? A typical label is going to indicate the nominal system voltage, the arc flash boundary, as well as one of the following, either the incident energy and its corresponding work distance, or its arc flash PPE category, or one or the other of these two, but not both. It's also going to show the minimum arc rating of clothing or site-specific PPE. Here's a sample picture of one of the many types of labels. There's no required format, but it just must convey all of that information. I'm going to now turn the time over to Noel McCaddies, and he can share more. He'll share more with you about PPE training requirements as well as other information. Noel?
Okay, Keith. Thank you. Thank you, Keith. Good morning, everyone. All right, this morning I'm going to cover the next three subjects, where are going to be the 5 key revisions for 2021 in accordance with NFPA 70E, personal protection equipment, and the training requirements. So, getting started here, Article 110. The big change here is that this article is requiring employers to include an electrical safe work condition policy. So you may want to pull out your electrical policies and then look at this and make sure you have that included into your work condition policy to make sure we're talking about the general requirements. Article 360 is titled Safety Related Requirements for Capacitors. Again, this is where they've actually added more attention to these energy storage devices such as conveyors, heating, cooling, and airflow. Section 350.9, which has been revised, is revised to include energy thresholds for electrical equipment and systems in laboratories. Down in the bottom of the bullet statement, the addition of Article 360, the capacitive circuit threshold, was deleted to avoid duplication and potential confusion according to NFPA. The fourth change, or the fourth revision for that, was that they included a revised table 130.5C. Keith talked about that earlier in his presentation. So this is designed to be used to help estimate the likelihood of an arc flash incident. The reason for the change is to make sure the standard is being used properly. And the last revision was done to the two general 130.1 and 132 general and the energized electrical work permit. They've been rewritten, so to accommodate information moved from other portions of NFPA 70E. The results is more detailed focus on safety-related work practices, assessments, precautions, and procedures when an electrical safe work condition can't be established, along with elements and exceptions of a work permit. Moving right along, when is PPE required? He talked about this a little bit in his presentation. This is the one that's been revised. If you don't, just went over it, explaining that the revision included Article 130.5. So you may want to go take a look at that. If you don't have the new revision document, you may need to get a copy of that so you can be in compliance to understand what the changes were and how does it affect you or your business establishment. This is another one that was just covered. One I think I want to bring to is like, during some of the visits I go out on, the consultation visit, I pay close attention to see if I can find this tag on the circuit breaker panels. I've seen this out there in the workforce or at workshops and stuff that I've visited. And here, as we have Keith alluded to, this is a hazard boundary where the qualified technician is put in the distance here for that boundary, and then has an arc rated suit. He's put everything here for you to be in compliance with. So when your technician goes out there, it may not be, this may not come from your department or your company. The actual people that have outsourced this and got this assessment done, or the technicians put this on the panel. This is to help your technicians to identify what that other qualified technician is requiring that person to do before they touch the panel, and make entry to the panel to do risk assessment, repairs, or whatever. So make sure you pay attention to this. So let your effective employees know that these are out there, and they should be annotating and documenting this into their, your work assessment. Shock hazard when exposed is giving you the volts. Limited approach, non-qualified boundary, 3 to 6 feet. Restricted approach qualified with protection, 1 foot. And exposed, and it's giving you here, telling you it's class 0, which is the minimum you can have for a class for PPE. Insulated tools is what this technician requiring you to have if you're going into for a shock hazard. Flash hazard, of course, things changes. So make sure you're paying attention to this placard. If you see it out there, have your personnel, take a picture, document it, so you can put it into your work order, so you'll know that it has had an arc flash assessment been done. Some of the things we want you to know when the PPE is required: clothing design, protecting your employees from head to toe. So a lot of time we get out here and I'm on a site visit, and I want to know if that PPE that the individual is wearing, especially my electricians or people that are going to be exposed, I'm looking for, some type of labeling to help me out, to say, yeah, this is in compliance with electrical standard, or, it's insulated to be used around electrical circuits. So make sure you're doing the same thing. Here's an example of electrical gloves. Shall be inspected before each day's use and immediately following an incident. How many of you out here having some checklists where, the technicians are checking their gloves before they go in and use them? I'm not sure it needs to come to that, but maybe you want somebody, or you want to put something in place that will put somebody responsible to report what the condition of their PPE, especially when it comes to gloves. Here's some problems to look for: cuts, tears, snags. Those are some things we see out in the industry when you have people working in close proximity with sharp components such as a circuit breaker panel, or removing panels and installing panels. Here's another one that we look for: leather gloves. But the leather gloves got to be designed to protect voltage rated gloves from physical damage. These goes on the outer part of the rubber gloves, but then you got to make sure again that the technicians know how to put them on and they're not causing them any problems when they're using them. So also outside of this, make sure the PPE is, when you're giving it to them, you're training them on it. Foot protection. Foot protection is really important. Sometimes, when we go out here and as a consultant, I'll, again, take a look at their footwear. I'll try to see if, if the footwear is rated, well, to be, in an area where energized circuits are being operated, being used, or being where a component of a circuit breaker panel or switchboard or whatever operation that they're performing, that the footwear, foot protection is in compliance. A lot of times I'll see something out there and it may not have that rating on it, but then later on I can go back, or I have the employer send me information to confirm that the footwear is designed to be used in and around electrical hazards. Here's a hearing protection. We talk about, when people out there operating in and around workshops or job sites, a lot of times, the hearing protection may be something that may be required as well. And then when, you're doing your risk assessment, make sure you are looking at that and identify that they also are rated PPE, so that employees are using something that's been identified in the industry to be used in and around electrical hazards. Insulated equipment, a big one. This is a big one because, again, when I do make visits or you have tools and, we ask the question, how do you know it's rated to be used in and around electrical circuits? a lot of times, you know, the actual qualified technician, they know to tell me, hey, Matt, they got the double triangle designation on it. And I say, show me. And sometimes they're on there and sometimes it's not, meaning that they get wore down over a period of time. If anything that's on the actual equipment needs to be, I ain't saying replaced, but you know, you might think about replacing them or give me some type of, I'll give the employee some type of information that says, hey, yeah, they're still good, you know, even though this may have been deteriorated, we still look at these insulated equipment that's been capable and able to do the job. So we look for that. And, you know, you want to look for that too. You want to make sure you do 100% of inspection or make sure the employees are doing it to ensure that the specification for insulated hand tools is affixed to the tools or already available. So if anybody asks, hey, can you show me that they're rated for to be used around electrical circuits? You don't have to look for it. It should be easily afforded to the inspector so they can go ahead and, you know, make the determination that you're in compliance. Another one is the insulated equipment here. We're looking at this fiberglass reinforced plastic rod. The key here is not just making sure it's labeled, but, you know, test it. I know out in the industry, equipment changes or the manufacturers change equipment. One of the things I want to bring out to the participant this morning is that I always go back to the manufacturer recommendation. You know, when you buy something, open up and just don't issue out the equipment. Read what the manufacturers say and then see if it's been required to be tested for 2 years and put it on a preventive maintenance program or something like that, or you can send it out to get it tested if it's required. Arc rated again, thinking about the head protection, need to be in compliance with ANSI Z89.1. Here's a nice pictogram that talks about the different categories from category 1 to category 4. Being category 1, you're looking at the minimum arc flash rate hazard of 4 cal, then it goes up to 8, 25, 40. So you see the actual pictogram depicts a different level of what type of PPE is required for the individual to wear. So this is a good chart to give you an indication what you may need to follow in case you are identifying this, then here it gives you some indication again to make sure you're in compliance with the proper PPE. Another type of head protection. This is now using a face protection from Arc Flash. And this is the one with the cloth. This is a cloth material standard. You can see this standard is different from the one we just seen. So a lot of times out there, you may have a requirement to have a cloth compared to just a face shield. And this has also a good face shield. So, you know, it depends on, again, you see the labeling here, you know, based on the exposure assessment was done. So maybe the level of head protection had to be increased. So take in consideration whatever the exposure is going to be or that your employee is going to have to go out and do the work, you then need to go back and take a look at your PPE to make sure it's applicable. Operated rain gear. A lot of times being here in Florida, we talk about rain and, coming into the rainy season, but throughout the country, doesn't matter where you're at. Your employees may have to go out and, give you a sunshiny day. And next time you turn around, you may have a rainstorm. Make sure you're looking at your rain gear and then it's rated to be in compliance with the hazard as whatever the exposure they're going to be going into. What type of arc flash that they may have to be exposing themselves to. And then if they have to put another rain gear on, it needs to be in compliance. You just don't go use the basic rain gear. Then it doesn't meet the intent of the standard. All right, moving into training requirement. I'm going to just go over some basic training requirements, requirements for qualified and requirements for unqualified. 1910 332A gives us a definition. Training requirements apply to employees facing risk of electrical shock, not reduced to a safe level by installation specification. And they give us another standards there, 1910.303 through 1910.308. Training shall include, keyword shall, safety-related work practices and procedures and to provide protection from electrical hazards. Here we go. Here we're showing that in these two pictures here, that the individuals are plussed up in their, appropriate PPE. This individual here now demonstrating they're using an insulated rod here, maybe to, turn off or turn on the switch gear. This is very important. Why I like this is because even though this is a picture for our presentation, it's good for training at your location, but get training or get pictures taken of your people actually doing the training so that you can build on that. There's something out there that you are doing or you require your employees to do, put them in the appropriate PPE. Just sitting in the classroom, in a climatic classroom without the PPE on, you may, make it easy, but once they put that gear on, you'll see a big difference in employees. They may not perform as good as you think. A lot of time when we're out there, we want the employees to be in a position where if the temperature normally is, with short pants on or long pants, it's, 70 degrees. So as you put that gear on, your body temperature goes up 20 degrees. What are you going to do? How do they react? A lot of times, again, that's when you find out that, well, that employee may not be able to do the job as effectively as you think. You may need to have two people to do a job. So one of the training I always emphasize is just to be administrative. Go out there and, make sure that you're observing the employees operating in and around the actual activity that they need to perform. It could be inside, outside, but put that PPE on, let them walk around 15, 20 minutes, see how they're doing in the area that they're required to do the work. All right, here we go. If exposed to elevated risks of injury by exposure to electric hazard, training shall, and here we got some bullet statements that you shall be training, means you have to be training the people to meet these identification here. As like number 2, how each electrical hazard affects body tissues. Down here, I'm looking at what PPE is needed for the employee to execute his or her work assignment. Very good. This is again, that's assessment. You saw that, I gave you that one slide where you saw the category from 1 to 4. You understand? And, we talked about if there's a, elevated exposure of arc flash hazard, then the PPE has to be identified. What type of PPE you want that person to put on before they go out there. So you want to do that as well. And again, how to select and spec in PPE. What employer provide procedures, including specific work practice the employee must implement. Again, risk assessment, job hazard analysis can be something that, we use fluently out there. So when you're having someone to have to respond out to a work site or job site or whatever, make sure, you understand that if the individual or you don't have something there that shows what that type of exposure that they're going to, that they do that themselves and report back to whoever is going to be the qualified person. That person should be the one being qualified that goes out there. All right. All right. So we're going here again with some more training requirements. And, one of the things, again, I'm always about is how increased duration of exposure to an electrical hazard results in a higher frequency of injury. This is really important. Again, I can't emphasize that a lot of time when we send people out there, and if the person you're sending out there, again, the temperature work condition changes, and they are supposed to be there for about 10 to 15 minutes, then all of a sudden that job turns to a 30-minute job, what are we supposed to be looking at? You're supposed to be looking at the person's physical condition. Maybe they're losing a lot of water, they need to hydrate. You want to take in consideration all of that. Down here at the bottom, how to interpret the informational equipment labels and select appropriate PPE. Very good one. This is why when I do go out again, I always ask the employee, hey, let me see your gloves, what I'm looking for. I want to see, even with the PPE, I want to see the labels. If his labels are fixed, the equipment they're using, there's a label that indicates this is used for or identified to be used around electric circuits. So if those labels are not affixed, then technically we want to take that out of service, until you can get the applicable label or replace the equipment. This is a very good one. A lot of time when we're thinking about sending the people out there, We don't think about maybe having emergency procedures already established. Here down here says employees shall be trained in methods to release victims from contact with exposed energized electrical conductors or circuit parts. Very important. If you're not out here practicing how we're gonna rescue the employee in case he or she gets incapacitated from the use around the electrical circuit, then it's too late. You need to practice this. So if you fail to plan and your plan will fail, that's basically one of the things I always talk about. So not only do we practice with the actual PPE and working around the circuit, let's continue. Let's say with the what if something happened, how are we going to remove that individual from that area, maybe to an outside area, so you can continue to try to save his or her life, because all your employees shall be instructed in the methods of first aid, CPR, and AED. So all your emergency training should be encompass all of this as well. So when we practice this, let's continue to see how we're going to perform CPR, and do we have an AED on site to be used in case a person needs to be to be energized to try to restart his or her heart. Qualified person. Normally, this is when we look at someone that's been trained and knowledgeable. And I looked at the other standard here, NFPA 70E, and they got another word called skill in their definition. So, and this is part of the construction operation of equipment or a specific work method, and be trained to recognize and avoid the electric hazards that might be present. They also be familiar with the proper use of the special precautionary techniques, PPE, including arc flash suit, insulating and shielding materials, and insulating tools and test equipment. Stuff that we've been talking about throughout this webinar. It all comes down to make sure that we training the people out there correctly. And just giving them the PPE and sending them on the job is not training them correctly. That's more than that. I always emphasize the importance to take pictures, maybe do videos, get the feedback from the employees again. These are the things when you're out there, when we're trying to, before we get them exposed to something that they're not familiar with, let's go get them trained. Let's make sure they're able to do the job correctly and safely. Here we go with some new pictures, other pictures here that talks about what kind of skills and techniques necessary to distinguish exposed energy. So these pictures, again, is good administratively to have the employee identify and then do a Q&A with them. What type of PPE would you want to use on the slide on the left side? What type of PPE would you want to use on the slide on the right side? Nice Q&A to get them, some ideas how they're supposed to be looking at things even before they go out to the job site. So when they go out to the job site, the same thing, can you identify what's your arc flash hazards? If it's, do you have the right PPE? If you don't have the right PPE, then of course, they should elevate that back up to management and make sure you guys do the right risk assessment to protect the individual, have the individual protected with the right PPE. Additional training that might be required for a qualified person, skills and techniques necessary to determine the voltage and exposed energized electrical conductors and circuit parts. Very good. Qualified people, we definitely want them to continue to be able to demonstrate this. One in particular situation, I went to a construction site and I saw the voltmeter. The voltmeter was beat up. It was not really legible. I didn't understand what was going on. I don't have to be an electrician to know I didn't think that voltmeter was serviceable. But then when I asked the individual about it, come to find out it was something that he brought from from Brazil. It had nothing to do, it had no other labels on it. It was a Brazilian voltmeter. And sometimes I look at voltmeters and you turn them over, they need to be sent back for PMI, to be recalibrated. Remember the insulated stick was up here every 2 years. Take a look at your equipment. Don't just assume when you buy it, it's good to go for the next 5 years. The manufacturer may require you to send it back in to be recalibrated. So also make sure, again, that the technicians or the qualified person is able to use your equipment effectively in the right way that's designed by the manufacturer. Additional training, again, decision making. Remember I showed you the 2 slides before and saying, hey, ask the employee what type of PPE would you want to wear in this picture. In this picture, same thing. So they need to be the one that also, being as the qualified person, can identify if their PPE level is adequate or inadequate. So, and then if the hazards associated with working in and around that, don't just go with the electrical arc flash. Sometimes when we think about this, you may need to look at the type of entry they got to make. Are they going into electrical vault? It's really close. There's a lot of things out here that electricians and technicians have to get in close proximity where they don't have a lot of wiggle room, and they're, up against the actual front face of a circuit breaker panel or energized equipment, and then they don't have a lot of space there to work. So let's make sure they know how to do the risk assessment as well when they go out there to the job. Here's a nice pictogram here talking about what we look at for an unqualified person. This is the person we don't put in any PPE. So he or she knows they're not allowed to go anywhere inside that arc flash boundary. They're on the outside. That may be the person you need. Again, when we talk about your emergency procedure, he or she might be the one that's going to stand there and be able to, raise the alarm. Now, if you have a qualified person, again, I've seen this happen where, that you may have 2 qualified. So he or she could be plussed up, and that'll be the person, be the emergency person, try to rescue the other individual. But if you're not practices then, and you're not sure, and like I said, if you send one individual in there and that person go down and you're not hearing back from them because you didn't have an extra person on the job site, that's going to be on you. But this is why it's important that we do the risk assessment. And before we put the individual in harm's way, think it out. And like I said, this person should be trained in and be familiar with any electrical safety related practice necessary for their safety. You see these cones? I like that. That's what we want. If you're going to prevent cone tape, we don't want this person going nowhere inside there. So that'll be your unqualified person. Retraining. This is one of those things, again, by chance, I did have opportunity to talk to someone that's in the power industry, and he told me that he had to do a retraining for a couple of personnel. And I said, did you observe them doing anything? He said, no, I didn't observe them. He said, but when they came back with their worksheet, I noticed they didn't tick off certain things that, gave them, made them think about, wait a minute, y'all not ticking this off. Are you really doing it? He didn't go into detail. So what he did was he just brought everybody in. He didn't pinpoint them. He brought everybody, or, got everybody into a classroom setting and just reiterated the importance of making sure you check your checklist. So, but, things like that can be, it can indicate to you if the employees out there may not follow through, or again, with the checklist that you have for your agency or your company, you may want to start retraining them on that. So here says if the supervision or annual inspection indicates that the employee is not complying with the safety related work practice, i.e. same thing, your checklist, if that's part of your safety related work practice, that checklist must be completed, signed, dotted, whatever. And if it's not, then you may want to think about maybe doing some retraining. Okay. I see this a lot out here now in my visits. New industry, a lot of stuff's coming in that is a lot better than the old electrical boards that they're putting in these buildings. New technology. So again, changes and stuff out there. If you see stuff that have been something that you're not trained on, you want to get out there, or make sure the employee identify, hey, I wasn't trained on this, or we need to get additional training. Let's do that, because this change is quicker than how you call it, the stuff that I look at. Sometimes I see an old building, they still got the old circuit, but as soon as a new building come in, we start seeing new electrical boards, electrical panels that may or may not been something your guys or girls or whoever been trained on. So you want to make sure they also get training on the new equipment. Don't just take it for granted that they've been trained or they understand. So again, continuing retraining is where if employees employ safe or related work practices that are not normally used during his or her regular job. Again, same thing, the employee should be reporting back, hey boss, or hey, you know what, this panel or this electric circuit is something new. I'm not comfortable with it. I think, I need to get more training. Don't be ashamed. Let them know to report it back to you so you can take action to ensure that they get the training necessary before they try to do something that will get them exposed to an arc flash. And last but not least, employee training. Documentation. Verbal is good, but I always tell someone when we're out there doing a consultation, I say, but verbal doesn't work in the court of law. So if you're trying to say, if you ever get in a situation where you need to show that you did some training and you don't have no documentation, it's like it never happened. So it's important to identify with the content of training, the employee name, and the dates of training. And again, if you keep those on file, as long as that employee is gained, and it's gainful employee with you, or I don't know, even after they leave, I say just maintain it, soft copy, scan it in, have it on file just in case up. So please make sure your training is documented, and that people can go back and verify it, because we all believe in ensuring that if I'm on to verify the training has been done, I'm going to look for documentation. I'm looking for real signatures and dates. Okay? So with that, I'm going to turn it back over to Nick.
Thank you, Noel. And at this time, we'll now take questions from our audience. Our first one being, do the assessment labels expire? This is open to any panelist.
I do not believe they do expire unless there are any significant changes to the component, maybe changing out breakers, changing out service, that might warrant the expiration of that label. Anything that would change the values on that label would put that label into expiration.
Thank you, Keith. Our next, if working on something energized, do you need to have a spotter?
I'll take that, Nick. Remember, I just went over the training where we talked about the unqualified person that's standing outside. That's where you have to make your risk assessment. That may be more of a determination that you may have to enter into a circuit that's going to expose the employee to something that may be a arc flash or arc blast. Yeah, you may want to consider having a spotter, but not necessarily if you depends on, like I said, the work they're doing. If they're just out doing general maintenance, doing a visual, I don't think so. But if they're going to have to go and do internal or maybe do installation or removal where they cannot de-energize, or if they have to do all the de-energize, you still may want to consider putting that spotter there until you can determine that he or she not longer needed. That's something we can't just say yes or no right now. Every situation will be unique. That's what I'm saying is that you need to make that determination yourself if the spot is required.
Thank you, Noel. Our next question. If a risk assessment has been completed prior, is it valid for X amount of time, or does a risk assessment need to be completed every time?
If you're going to be working on energized equipment, I would do a risk assessment every time to ensure that there have been no changes in the conditions from the last risk assessment. Okay, that would be my guidance on that.
Yeah, if I could add as well, and Keith is absolutely correct. This is probably covered under management of change as well. So your MOC procedure in the company would highlight when another risk assessment will be conducted. So any significant change in the task or the event would require you to do a risk assessment. I don't believe there is a certain timeline to assess the validity of a risk assessment. Once there's a change, a substantial change, a new one needs to be conducted. And I know McCaddy, Noah just talked about risk assessment again. I'm not sure if he wants to chime in on this one as well.
Yes, sir, Dr. Ward. And again, for the participants, this is very important in a situation where risk assessment. Remember, I was telling you about where the guy determined that the checklist wasn't being filled out. It was a risk assessment checklist, and what he did was he had an old risk assessment, he had a new one. So he realized the guy wasn't really looking at the filling out the new one to indicate that the systems and everything was still applicable, and that was how he determined he wanted to do a retraining. And that's really important, as Keith and Dr. Ward has alluded to, that we definitely want to be training the employees to continue to do risk assessment, because things can change from one, especially if you are, in a situation where things have maybe changed in the last 6 months. Somebody's come in and did some other work to the system, added air conditioning, HVAC, maybe changed the whole panel. So yeah, if it ain't changed, then the guy's just doing checks and redating it and then turning it back in. It's being no changes found.
Our next question. How do we keep expenditures for health and safety low for a small, recently opened manufacturing company?
Okay, I'll take that, Nick. One of the things that we emphasize, and Dr. Ward alluded when he opened his statement, is by using your nearest consultation services there in your state. Here in Florida, being that we're the point of contact for small businesses, I always emphasize why contact us so we can come out and assess or help you assess your safety plans and program, because there may be more to it than just for arc flash hazards and stuff like that. We do a comprehensive visit where we look at all the related safety plans and programs that may be applicable for that industry. And if you want to keep the expenditures low, I can only tell you, the service we provide is free. I don't know how low can you go with free assessment by using your nearest consultation services. So with that said, best way to start is we're using your local consultation services to do the self-assessment with you as far as related to your company's industry and then your safety programs and plans.
Yeah, the only thing I would add to that is as well, and Noel hit it on the head. The consultation program tries to do an assessment based on risk as well. So, like the previous question in regards to risk assessment, one of the things we try to do is work with any company, small employers with high hazard operation, to identify what's most serious hazard in the workplace that they ought to try to put some controls in place for. So when we leave, we give you a list of items that need some attention, and from a programmatic standpoint, and also from a management system standpoint. As I mentioned before, this is a targeted consultation process for the company based on the activities that you do. So we do keep that in mind in regards to trying to minimize the amount of expenditures that you will have for a particular company. Again, targeted for that specific company.
Thank you, Dr. Ward. Our next question, a request. Can you address the rule around locking and securing of electrical panels and the marking and identifying of the circuits within?
I'll take that one. And I'd like to address the second part of that question first. Marking and identifying the circuits within electrical panels, that really is a requirement. OSHA requires it, as well as NEC, the National Electrical Code. When it comes to locking and securing of electrical panels, that has become somewhat controversial, especially when it deals with OSHA's requirement that electrical panels be accessible. And if we consider the National Electrical Code definition of accessible, it means not behind locked doors. So if we look at it from that standpoint, electrical panels must remain unlocked to be accessible. However, there are a number of jurisdictions, and here in Florida, I have personal experience with one county where the local building inspector required the panels to be locked. So the employer was up between a rock and a hard place, so to speak. What does he do? Does he hack off the building inspector, or does he run the risk of getting penalized by OSHA for locking it and making it inaccessible? Well, this particular employer opted for an alternative. He had his electrician install a disconnect switch on the supply side of the electrical panel. So in the event of an emergency and the need to access a breaker in that panel to turn it off, he could still keep the panel locked, but he could kill power to the entire panel with a single swift action. So that's how that employer beat the quandary. But OSHA requires that panels be accessible. They don't specifically say they have to be kept unlocked, but if you look at the NEC definition, you will see that it says accessible is not behind locked doors.
Thank you, Keith. Our next question. As an equipment service company, how do we determine arc flash panel ratings to determine PPE requirements?
I'll take that one. There's a number of ways you can do that. If the panel is not already labeled, you could have a consultant or a qualified person come in and determine the rating for that panel. But typically, you should see that arc flash rating for a panel established by the manufacturer. And that might be the one to rely on, is the manufacturer's rating of that panel for arc flash.
Our next question. Does OSHA enforce NFPA 70E?
I'll take that one too. It's simple. No. OSHA does not enforce NFPA 70E. They do, however, as I said earlier in the presentation, they use NFPA 70E to back up their issuance of a general duty clause violation, because they can link the violation to a recognized hazard under NFPA 70E.
Our next question. Is it required to have an electrical safety label for low current, such as 240 or 120 volts or less? For example, a household electrical circuit breaker. Also, should PPE work if you need it to flip a circuit breaker from on to off, not conducting any repairs?
I'll go ahead and take that one as well. The arc flash issues do not apply to dwellings. Okay, you do not have to have all of the PPE protection for the dwellings. They really come into play in an industrial setting and industrial grade equipment. So the standard explicitly says it does not apply to panels within dwellings. And if you're simply going to be flipping a circuit breaker on and off, PPE is not necessarily required. There is a safe way to flip a circuit breaker on or off, though. Basically, you do not stand in front of it. You stand to the side where you have least exposure should something go wrong. And again, if this is a 240, 120, it's not going to be a very significant. I mean, it'll be a significant arc flash, so where you probably have to go change your clothes, but it's not going to be an earth-shattering arc flash or arc blast. And we saw that within the one table where they labeled a 240, 120 or less panel as requiring, in an industrial setting, again, is requiring a category 1 PPE, which is the lowest of the PPE categories.
Thank you. And our next question: if the assessment label is missing, would one even work on something energized?
If the assessment label is missing, it might cause a delay in working on it should create a delay in working on the piece of equipment. At a bare minimum, research should be conducted to be able to find what the information was that was conveyed on that label. And once you have that information, then you can address the appropriate work practices and the utilization of the appropriate PPE. Okay. But again, OSHA doesn't require a label. 70E does. Okay. So just because the label is missing doesn't mean you can't work on it, but you still have to do the risk assessment, which would provide you all of the information that the label would otherwise.
And we have a few more questions here that are now coming in. Our next: what are some best practices to look out for when inspecting employees working with voltages less than 50 volts?
Repeat that question, Nick.
The audience member is asking for some best practices to look for when inspecting employees working with voltages less than 50 volts.
There are minimal requirements for under 50 volts, very minimal. In other words, it's like changing a 9-volt battery out of an old radio or replacing a low voltage thermostat. You'd probably want to utilize insulated tools to avoid shorting anything out, but as far as PPE goes, there's really no requirement there.
How often is retraining required?
Okay, retraining. Well, we talked about that. That's where, if the employer identifies that the employees out there are not, following the standard operating procedures that they have set for, the technician or the qualified person to go out and perform the work. And that's another indication that retraining may apply here. Remember, I used the scenario where the actual manager identified that proper paperwork wasn't being filled out, risk assessment, for example. And he thought that was a trend that was not really good because he didn't see it from one technician, he saw it from another. He just explained to me. So he started doing retraining. Now, a lot of time managers can't go out and observe the employees performing or not performing correctly, but that's another way of doing it. Also, another way of looking at it is if the company requires them to do inspection of the PPE. Remember one slide there, we say the gloves should be inspected daily. Hopefully, if management out there want the employees to comply, they have written requirements. Their risk assessment should be, the risk assessment should be done every time. If there's some indication that's not been done, or they find out that through other means that the employee is not performing right, then retraining would be the order of the day, to get the guys or girls, whoever's out there, bring them back in and get them retrained.
Thank you. And it looks like we have time for one more question here. Can the employer use the table 130.5 as a guide for hazard assessment and label their panels as such?
No, you cannot use the tables for the basis of a label for the panel. The labels on the panels are the result of performing a risk assessment, calculating the incident energy, and establishing the arc flash boundaries from that data obtained through informative Annex D, I believe it is. Okay, so no, the tables are an alternative to going through as far as identifying certain parameters, as opposed to going through the actual calculations in Annex D.
Thank you, Keith. And that concludes the question and answer portion of today's presentation. I want to give a special thank you to our presenters and our attendees for your participation in today's webinar on NFPA 70E, Electrical Safety in the Workplace. If you have not yet completed the survey, please take a moment to do so now. The survey can be found in the questions panel. I will leave the presenters' contact information up for a little while, so you may jot that down should you have any additional questions that weren't answered. This concludes today's webinar. Thank you for attending.